Back, everybody. Time for a retrosynthetic analysis. I chose this one because it's closer to the level of difficulty you're going to have on your exam. You'll notice some of these get pretty elaborate on older exams. And here we have something that's closer to yours. You will be forced to use an acetoacetic ester synthesis or a malonic ester synthesis. And I just want to remind you that that synthesis is used to make acetone targets. They must have acetone in them. Yours does not here. And I'm pretty much just saying it out loud because you're doing a test that had carboxylic acid derivatives as a major topic. It seems to me the malonic ester synthesis is more appropriate because all the targets will be acetic acid targets. So if you can find acetic acid or some derivative of it in your molecule, then a malonic ester synthesis is what you need to use. I just circled acetic acid. Yes, it's an ester of acetic acid. You must incorporate a malonic ester synthesis. Okay. It's not an ester of acetic acid. Shame on me. I should know my functional groups by now. It's an anhydride of acetic acid. No big deal. We know how to make anhydrides too. We did one earlier in today's multiple sessions. Anhydrides are made from an acid halide and a carboxylate. You can go either direction. They're perfectly acceptable, each one. So on this example, for no particular reason, I'm choosing this to be the acid halide, and the carboxylate will be our acetic acid derivative. Has an isopentyl group over here, and not a benzyl, but a homobenzyl group. Look back earlier in today's review notes, and that word homobenzyl came up. It's benzyl with one more carbon. Benzyl is up to here, isn't it? Okay. Now, where do acid halides come from? Acid halides come from carboxylic acids. It's the only way we learned ever how to make them. Where do carboxylic acids come from? Do they come from alcohols of 5 carbons or less? Not this one. Oh, benzyl alcohol. Yes, benzyl alcohol. Oh, please let me know that nobody for the rest of the semester is going to lose the same points again for not remembering that this is benzyl alcohol. Phenyl CH2OH, benzyl alcohol. Circle it. This is the conjugate base of an acetic acid that has 2 alpha groups. So I'm just going to go slow here. There's your acetic acid right there. It has 2 alpha groups, indicating that a malonic ester synthesis would be ideal to make this target. This is your target. That right there is a malonic ester synthesis target. Malonic ester synthesis target. Malonic ester synth target. Do you know how I know that? Because it has acetic acid in blue. All the way up to here is acetic acid. Okay. What it came from was a malonic ester with the 2 groups on it, which then underwent saponification, acidification, and decarboxylation. So it used to be a diacid there, and we'll put it in blue. It had 2 carboxylic acids. This one, the only reason it was there was so that we had an alpha carbon that was alpha to 2 carbonyls. Okay. And that is a malonic acid with 2 alpha groups. It needs to be a malonic ester so that you can access the alpha position. So ethyl's very popular as the ester. There's a malonic ester. It's got your 2 groups on it. 1, 2, 3, 4, V. CH2, CH2, F. Okay. Malonic esters are nice because that they easily let us make either that bond or the other bond from the same position. So we're going from this position here. We're making this bond apparently last. And a little short form here, ETO2C. I have 2 of those attached to the black C, that's the red dot, anion. And a bromo on homobenzyl position. Groovy. We'll make that. And we'll also make this. Well, that one's easy. That is the conjugate base of an acid with a pKa of 10. 2 of those. Goes to a C that has an H and a homobenzyl group. I also know how to make that bond. Same protocol. ETO2 C taken twice, CH negative plus, wait a minute. I didn't do this right, did I? Sorry. We had the isopentyl still on there. It wasn't a wrong approach. It just wasn't corresponding to this. This is the group I just put on. It was the group down here, not the group up here. That group's on. Now, how did it get on? Well, I got on when I had a BR attached to an isopentyl group. And these 2 combined. Now the 2 retros are, where'd you get that from? And where did I get this from? I got that from an alcohol. You can't circle it. It's not benzyl alcohol. But on our first test, we learned how to make things 1 carbon longer using things like organolithiums or Grignards and formaldehyde, which comes from methanol. That's a pretty bad looking retro arrow, isn't it? Circle that. That's not methanol at all. H3COH. Circle that. And organolithiums come from organic bromides, come from organic alcohols. BrCH2 comes from HO CH2F. That you can circle. Benzyl alcohol. This you can circle. Comes from isopentyl alcohol, 5 carbons. You are not finished with your malonic ester. This is the conjugate base of diethyl malonate, so it came from diethyl malonate. ETO2C, taken twice. CH2, diethyl malonate, comes from malonic acid. And ethanol, circle it, sure. Plus, here we'll even draw out the malonic acid. You're saying, wait, malonic acid's not on my list either. My goodness, does this thing ever end? Alcohols or diols of 5 carbons or less. Well, we have a diacid, which came from a diol of 3 carbons. Circle it. And after that, we're going to come and do our, save it. Thought I say, there we go. Do our forward synthesis. Big picture forward synthesis coming up. How did you make the diol into the dicarboxylic acid? You're going to say, I'm going to use CrO3H2SO4, and don't forget water. How do you make the alkyl bromide from the alcohol? PBr3. How do you make esters from alcohols and carboxylic acid? Space is a little bit tight, so I'll go with HOTS. You need some kind of strong sulfuric acid derivative, HOTS and DST. I don't even have room for DST, do I? Think small. You don't have to put DST, it's optional. And then how do you take the beauty? So the whole beauty of the synthesis is it's so easy to take this H off. You can use something as simple as NaOH. Okay. And there you go. NaOH makes that. These two combine to make that. You don't need to show anything else. Just show them combining. Taking the H off was just as easy here as it was previous. NaOH. Take advantage of that alpha to 2 carbonyls hydrogen. And then we just need to mix these two together to make that. Where'd that come from? PBr3 of the alcohol below. These two, you got to show me, this is not a simple mixing operation. Step 1 is mix. Step 2 is to put the proton on with HCl. How do we make alkyl bromides into organolithiums? Lithium and hexane. How do you make alcohols into alkyl bromides? PBr3. How do you make alcohols into aldehydes and not carboxylic acids? PCC. Yeah, I think we've got all the steps covered except the end when we have to start our rap song here. We have a diethyl malonate version of our target. So it's the ester version of the target. There's the target. You've got to get those carboxylic acids back. The nice, easy way is to do saponification first. Aqueous hydroxide works really well with esters. And then you got to put the protons on. You just say HCl excess. And then you could have After step 2, you could have gone step 3 and gone straight from here to here. But I'm doing step 3 here, and it's just heat. Beta decarboxylation is at the end of chapter 17. There's a new video for it found in the Q&A list, not on the normal lecture video list. So beta decarboxylation. And how do you make your alcohol into a carboxylic acid? Well, you use one of the other chromiums, CrO3H2SO4AQ, to make chromic acid, which makes the alcohol into a carboxylic acid. And very critical that you know how to make an acid halide, SOCl2, and pyridine. And how do you get the H off of a carboxylic acid? NaOH will do the job. Sodium bicarbonate would do the job. Doesn't take much of a base to do that. And then you just mix these to get your lovely target up there. And that brings to a conclusion the synthesis of that target molecule. I can't get it on one page. It won't let me go small enough. We're pretty close though. And you have access to these notes. All right, so that, I don't think we have any other participants, but I'm coming back after this to see if we do. Otherwise, this will be the end of today's Q&A. Look for the videos coming very soon. And keep studying.